Hello everyone and welcome to our webinar today. Today we're going to discuss how a major Australian university brought backup to the cloud with Amazon Web Services and NetApp AltaVault. My name is Mike Ruiz. I'm a manager of solutions architecture here at Amazon Web Services. I'll be your moderator today. We also have Chris Wong, Senior Technical Marketing Manager with NetApp, and we're very pleased to have Craig Muller, Platforms Team Lead with the University of Wollongong, to share his story with us today. Today's agenda, we'll keep it pretty simple. I'll lead with a quick overview of backup and recovery options on AWS. Then we'll hand it over to Chris for a discussion of NetApp AltaVault on AWS. And then we'll hear from Craig as he dives into his case study at the University of Wollongong. If all goes to plan, we'll have about 10 to 15 minutes left at the end of our session today for open Q&A and panel discussion. So let's talk about learning objectives. We want to learn how to streamline disaster recovery testing to be prepared for any type of outage or data loss. And in my experience, there's always opportunities to streamline those disaster recovery tests. So we'll talk about strategies for doing that. We want to learn how to empower your IT staff to retrieve critical data quickly, including long-term archival data. So quick access to archival data has been a pretty big challenge in my career, and we'll talk about options for doing that as well. Then finally, we want to learn how to transform a backup and recovery process easily from tape to cloud, so with an emphasis on that ease of migration. So without further ado, I'll spend just a couple minutes on a quick orientation of backup and recovery on AWS, kind of the core services and features of the platform that underlie backup and recovery motions. So first, what are some common backup and recovery challenges that our customers share with us? One is that manual backups are difficult to maintain, especially as storage needs scale up. And I think we know that that's the typical direction of storage needs. They typically go up in our experience. I won't belabor kind of the challenges of maintaining manual backup processes on premise, but I will note that those manual backup processes are especially attractive on AWS because the platform is so easy to use. It's so easy to like log onto the console and click create snapshot or make a backup, but that manual backups can be challenging even on AWS as our architectures become more complex and the number of assets that we have under management in AWS continue to increase. Manual backup processes on AWS also make it hard to effectively take advantage of advanced platform features like auto scaling, so as we scale in and scale out. So there's a really big opportunity for automation even within the AWS environment. Customers share that maintaining and building on-premise storage hardware is expensive. Probably don't need to spend a whole lot of time here either. In the case of backup and recovery, and especially archive, one of the components of high cost that I note in traditional infrastructures is the requirement to maintain multiple generations of recovery hardware on site, maintaining staffing with the appropriate training to recover from long-term archives. So archives can exist off-site for some number of years or maybe decades, and it can become a high cost encumbrance to maintain that chain of custody and maintain the ability to recover from those archival assets as time marches on. Together, these make compliance difficult, so manual backups, multi-generation hardware, and maintaining chain of custody over the long term for especially archival data and for backup and recovery can be very difficult. We need to demonstrate to our auditors that we have access to the data, that the data is recoverable, and this can become very burdensome in traditional infrastructures. So how can we meet these challenges using AWS? One is AWS Storage. The Storage Foundation on AWS is an integrated platform. It's a storage platform with adjacent services that work well together and that support the upstack services like database products, RDS, or Redshift natively and automatically. We've got a comprehensive API that demonstrates how the environment is used and protecting how the environment is used that exists across these various different storage services. This can create ease of use, but especially it can enable our partners like NetApp to take advantage of these integrated services to build complex products that are a little bit more tightly aligned with your particular use case. And we'll talk about that in some detail as we get further into the webinar. Security, AWS really thinks about security as job one. We think about it before we launch new services. We think about security as we add new features, as we open new regions. Of course, we're going to operate the foundational hardware in a secure way, but we're also going to offer you a common set of APIs to control access and define exactly who has access, a common audit artifact so you can look in one place and see who's had access to your data. And of course, we have comprehensive encryption offerings across our services, including in-flight, at-rest, and client-side options as well. AWS environments are easy to maintain. Of course, we're going to relieve you of the requirement to maintain hardware. AWS will maintain this on your behalf. And for backup and recovery, this is especially interesting because we'll maintain idle capacity either in region or in an alternate region to recover to. This can be a significant ease, especially as we're contemplating DR planning. The platform is scalable, so we're going to scale up and down with use, which enables low cost. We're only going to pay for what we use. It also enables interesting business and automation opportunities like full recovery testing, maybe even full recovery testing with every critical backup. So that's difficult to achieve in a cost-effective manner on-premise. It's available on AWS. So what are the AWS storage services that are most interesting in my view for backup and recovery? Like I mentioned that AWS Storage Services are a comprehensive platform. 3 services in particular are most interesting for backup and recovery in my view. One, Amazon Simple Storage Service, or Amazon S3, was launched in 2007, so it's 11 years young at this point. It's object store designed to store and access any type of data of any size and at any scale. Amazon Glacier is an adjacent service, so this is also an object store. So we're looking at key value semantics. So we have a name and we have data associated with that name. It's not a file system. But this is a similar service to Amazon S3 that's particularly appropriate for archival use cases where we don't need immediate access to data, but that we still have online catalogs. We understand where and when that data, where that data is, who's had access to it, and we can verify that it's available for recovery. And as long as we don't need actual access to recover within 4 hours, we can take advantage of Glacier and get a pricing benefit over Amazon S3. And then finally, Amazon EBS. This completes the story. This is block storage, so this is network attached block storage for our virtual servers. Amazon EC2 and other services like RDS use Amazon EBS for block storage. So this is important where we have small incremental or random IO workloads. Amazon EBS comes in a variety of different service types with different performance and cost profiles ranging from provisioned or defined IOPS to SSD or GP2 volumes, all the way to magnetic media for throughput or cold storage optimized workflows. The nice thing is that this storage is block storage that's decoupled from the lifecycle of the virtual machine. We can snapshot this EBS volumes. We can use those snapshots to build new environments, to move data around, to inform backup and recovery workflows, as well as to copy those volumes to other AWS regions to make the data available for disaster recovery or simply to scale out my application. These services work together. We'll talk about some of that integration in a second. But Amazon S3 is worth investigating in a little bit more detail. It's highly scalable object storage. I already said that, but what do I mean? It means that I can create an object in a bucket. That object can be 0 bytes all the way up to 5 terabytes for a single object. And there is no limit to the number of objects that I can store in Amazon S3. I can upload objects in parallel, I can upload single object elements in parallel, and I can download them in parallel as well with range gets. AWS will scale out both in size and performance automatically. I can, of course, store and retrieve data from anywhere in the web using the S3 native APIs or HTTP semantics. Objects that I place in S3 are automatically replicated to multiple availability zones with the effect of creating highly durable objects, 11 nines of durability per object in S3. I'm going to create bucket policies, ACLs, and leverage other AWS services that are integrated like IAM to protect these assets, define who, where, and when folks can access the data within Amazon S3. And of course, we have comprehensive server and client-side encryption. Server-side encryption on Amazon S3 can be enabled with a click of a button or a single API call. And our SDKs offer comprehensive client-side encryption. Of course, you can encrypt the objects before you flow them into S3. I mentioned that the services are integrated. Here's an example of an integration. I can flow data into Amazon S3 for active data. This may be content that I'm actively serving. This may be a backup that I may or recover from frequently or that I'm intending to immediately use for a recovery test. As that data ages out, I can automatically move it over to an S3 infrequent access, which uses exactly the same API but offers a slightly different cost model. And then finally, when that data becomes cold, and I no longer need immediate access, I can move that to Amazon Glacier. I can do this all through the AWS S3 API. and define that policy with Amazon S3 lifecycle policies. I briefly mentioned global infrastructure when I talked about how objects were placed in Amazon S3. So with S3, I'm going to choose an AWS region, one of the 16 regions that's available across the globe. I'm going to flow data into S3 in that region. S3 is a regionalized service. That means that I'm going to associate that data with S3 in a particular AWS region. S3 will automatically handle placing the data across the availability zones. An availability zone is one or more data centers, and there are 2 or more availability zones available in each AWS region. This gives me 2 benefits. I can define geographical backup and recovery and disaster recovery strategies. I can use S3 to automatically flow data from one region to another to place that or pre-position it for an eventual recovery. But it also gives me data sovereignty and helps me achieve my compliance objectives. Once I place data into Amazon S3, AWS will not move that from that region unless I instruct AWS to do so. So as an example, if I have a compliance or a regulatory requirement to leave customer data within the Frankfurt region, I can confidently use S3. S3 will distribute it around Frankfurt on my behalf. I'll achieve 11 nines of durability, but S3 will, or AWS will not move that data to another region unless I ask the service to do so on my behalf. What are some of the benefits of our Amazon Partner Network partners? So we talked about a pretty capable platform that's integrated and offers comprehensive SDKs. Our partners like NetApp use these SDKs to build workflows on top of these AWS services that are more tightly aligned with their needs and can enable features that are unavailable without additional automation. So opportunities for automation, if I've got manual process, our partners can help you achieve those objectives with policy-based backups, async replication facilities, use EBS and S3 together to build incremental backup strategies. And of course, it's all going to be cost effective with you only paying for what you're using on the platform. And finally, no conversation of AWS would be complete without talking about certification and assurance. Our customers tell us that they need to achieve certification and alignment with regulatory bodies. AWS works with these certifying bodies and assurance programs to help customers achieve their objectives. And these are both governmental, regional, and industry body specific. So as an example, HIPAA or gov.uk. So this is a short preview of the certification and assurance programs available. There's much more comprehensive information and a lot more logos on site that you can go investigate. So with that, I'm going to hand it over to Chris for a discussion of NetApp and AltaVault.
Thank you very much, Mike. And good morning, good afternoon, good evening, everyone. Really appreciate you coming on for this webinar. And I'm here to give you a quick overview of the NetApp AltaVault client and how it integrates with Amazon to really help ease and make your backup and recovery and disaster recovery strategies easier. I'm a technical marketing manager with AltaVault, been with the product here for about 7 years. It's been in the market for 7 years, and Amazon was actually our very first partner, of which AltaVault was designated. So let's quickly talk about what is an AltaVault. An AltaVault at its core is a NAS storage appliance that has cloud integrated connectivity to move your backup and archive workloads out to a public cloud. The concept here is that we are addressing a lot of the issues that Mike spoke about previously regarding the problems that customers have with protecting data as data requirements grow and compliance and regulatory requirements continue to press the amount of data that you have to hold on to for a number of years. So we have this idea of really helping to leverage the cloud to ease the capabilities of the requirements of a backup over time. So that is no longer having to concern yourself with the labor-intensive effort of managing either a lot of disk storage or a very, very large capacity of tapes that are moving on and off premise off to a tape vaulting service. And even the issues with security around moving that data as a physical medium, making sure that it gets on the truck, making sure that truck doesn't get lost, making sure that the data gets back okay, making sure that you can actually read that data back from the tape in a separate library, maybe at a disaster recovery testing site. All these issues that go around protecting and managing your backups is really what we're trying to focus on simplifying with this and really giving you a modern solution for the classic backup problem as you move along. And Amazon, as one of our key partners, provides that capability of really helping us to leverage the cloud scale, elasticity, and really the cost effectiveness to improve your backup recovery strategy. So from an Amazon perspective, AltVault will take that backup data from your environment, either through a physical AltVault appliance or a virtualized appliance, or even a cloud-based AltVault appliance in Amazon's marketplace, which we'll talk about a little bit later. And we'll store that data in one of Amazon's object storage tiers, such as Amazon S3, Simple Storage Service, S3IA, which is the infrequent access, or the Amazon Glacier long-term tier for those real deep and cheap archive requirements that several users have for their data. And really what we're trying to do here is, again, focus on giving you capabilities to match the data requirements for the tier that you'll be needing to hold on and recover your data from. So for example, if you're doing a backup use case and you need to recover your data fairly frequently, then Amazon S3 or S3IA would be an appropriate target for that, because you'll be recovering data on a frequent enough basis that you'll be accessing some of the data back from S3 or S3IA on a relatively frequent basis. And Amazon, with its low latency, will provide you that data back to your backup application very quickly. Now, if you're looking for something more like a cheap, deep dumping ground for all those project files, logs, archives, things of a nature which you want to maintain for a very long time due to some sort of compliance or auditory regulation, you can use Amazon Glacier to go ahead and protect that data for a very long time. AltVault works with Glacier to go ahead and make sure that that data is stored in secure formats for that extended period of time, and will store it in an efficient fashion for you, such that you'll be leveraging Glacier cost effectively, and then again only pulling back the data that you need at the time. Say, an audit comes down the road and you need to pull back some data for maybe some sort of activity related to that audit. One of the things that we point out is that we have the capability to provide you, really all the capabilities that each of these tiers provide. So for example, Glacier recently introduced functionality for expediting your retrievals of data. So its standard tier of Glacier provides a typical 3 to 5 hour access time. That is, you have to wait 3 to 5 hours for that data to come back. Recently, expedited tier from Glacier allows you to pull that data much more quickly back from Glacier. And AltVault is proud to have worked with Amazon to go ahead and provide that capability into our product as well. So giving you sort of the rich, full-featured capabilities that Amazon continues to develop, they come into our product very quickly as well. So the question becomes well, how do you move data into this object-based storage gateway and write that out to Amazon? And that is through the leading backup and archive software solutions today on the market. And these are really the enterprise level backup applications, such as the Veritas Backup, the Veeam, the Commvault, or the IBM Spectrum Protect. And we also now have support for NetApp internal Snap operations as well. So for those who are familiar with NetApp storage products, the NetApp FAS storage product family uses an ONTAP functionality called Snap Mirror to mirror a copy of this data for backup. That's called Snapvault. We provide capability for that into our product now, so that also can be used to directly back up volume-based data to an AltVault to Amazon Storage Services. So really the nice thing about having this capability is that from a configuration standpoint, when you go and upgrade and modernize your data protection strategy, you're not having to rip and replace everything in your infrastructure to make way for an AltVault solution going to Amazon. You're really actually just integrating a new storage tier capability into your infrastructure, such that your backup application doesn't point away from tape and begin to do operations to AltVault, so that you can now leverage all the modern technologies around AltVault to send that data out to Amazon storage. So the question is, well, what does AltVault provide me? Say that can't be done with other type of gateway. And really the power of AltVault is around the optimization and the security features that are built into the product. Again, being in the market for over 7 years, we've had a very rich history of developing features that are very targeted for the backup and archive workloads, and really understanding the requirements of trying to make and really, storage efficient tier of data management for data going off to a public cloud. So what AltVault does was it takes your backup data from your favorite backup application, again, whether it's a Veeam or a NetBackup. We'll go ahead and take that backup data over any of our NAS interfaces, and that can be a SMB or SIS interface. It can be NFS if you're on Linux. It can also be the Veritas Open Storage Protocol if you're using Veritas NetBackup Exec. You can go ahead and send that data to an AltVault over that connection, and then what AltVault will go and do is it'll go and optimize that data with a variable length inline based deduplication. That is, it'll chunk that data up. It'll go ahead and reduce the amount of data that has to be sent out by removing all the repetitive parts of that data. We'll go ahead and compress it with levels of encryption, and then we'll go and encrypt that data, with AES-256-bit encryption, where it'll stay at rest on AltVault cache storage of your appliance for quick restore and recoverability. That data format will then also be sent off in that same secure format to the cloud. So in this case, any of the Amazon tiers will get a encrypted version of this data for long-term retention, recovery, and disaster recovery capabilities. The connection that we established with Amazon is, of course, an SSL secure connection. So all your data is secure, again, on-premise as well as in the cloud end-to-end. So then the nice things about, having this inline deduplication and compression is it really can cut down the amount of data that you have to send out, as well as the amount of data that you have to store. And both of those are very good things because it removes a lot of the requirements around using Amazon as a storage target over your WAN-based or maybe dedicated internet connection. By reducing the amount of data, obviously you're going to be able to move the data to Amazon much more quickly and complete your backup windows. And then, of course, by storing less data in Amazon, you're also going to pay only the amount that reflects, those changed bytes between your backup versions. That's right. Really giving you that effective scale of cost as you grow out your backup policies over time. The security, really, I want to emphasize, is one of the key things that AltVault really prides itself on. It's not just necessarily of the data that's encrypted at rest as well as in flight, but all the security things around AltVault end-to-end, from managing the connections that we accept from backup applications, the management of the appliance itself, which can be done using a variety of techniques such as Active Directory integration, single sign-on, multi-factor authentication as examples, and then really role-based activities that you can use, therefore, to continue to enforce how data moves around and who and what users are allowed to work with that data and work with the appliance during the life cycle. We have a technical report that is available on NetApp that really describes all these technical features from a security standpoint in detail. And if you're interested, we can certainly share more information about the security features after this talk. One of the nice things about AltVault is that it's not only an on-premise solution for your backups and archives, but it also works in Amazon's marketplace. So that is, from the Amazon marketplace, as you can see here in the link, you can go and actually deploy a compute-based AltVault appliance within Amazon's EC2 or Elastic Compute infrastructure directly. And really, this is a great functional addition to the NetApp AltVault family because it provides you a lot of capabilities to do things more flexibly for, say, doing disaster recovery tests. No longer do you have to have a set of infrastructure at a secondary site. You can build up that infrastructure directly in Amazon EC2 cloud and deploy and cover all of your data back to this compute-based infrastructure in a VPC that you own in Amazon and test out the validity. Can I recover from a disaster? All of this can be brought up and running within 30 minutes and you can go ahead and recover your workloads that you either have on-prem or maybe that you're protecting in the cloud with an Alta Vault anywhere that Amazon runs today. So that could be for users that are, geographically located in the Americas and want to do testing, say, in the EMEA region or Asia Pacific region. All that capability is available today and really provides you, again, a true amount of flexibility to recover your data or to test recovery of your data wherever you might need it. And we have a lot of global companies that have a need for this requirement today because they're focused specifically on ensuring that the data can survive a regional outage of a disaster, say, a hurricane hits maybe the East Coast. You can now have that protection by having to be able to recover this data, say, in the West region of the United States. So having the functionality available physically on-premise as well as in the cloud really helps Alta Vault provide a lot of capability to customers for the backup and recovery needs. And with that, I will pass now the ball over to Craig with the University of Wollongong to describe how he uses Alta Vault and Amazon services within the context of his university. Craig?
Thanks, Chris. Thanks, everyone, for joining in to hear the story. So, University of Wollongong, platforms team lead. My team look after all the core infrastructure in the data center, including storage, backup, and disaster recovery. We're based 80 kilometres south of Sydney. We're a coastal city. We've got some beautiful beaches. I highly recommend people coming to visit. We're in the top 2% global ranking. We're also got a mission to become in the top 1%. So due to our size, due to our location, we need to be smart about the decisions we make, and especially when it comes to backup and disaster recovery. We can't just throw money at the problem that some of our industry competitors can do. So I'm hoping to give you guys some insight into the benefits of our design, the decision process that we went through to get there, and the lessons that we've learned as well. I think that's just important because our pain is going to be your gain here. Let's go back to 2015. We were in a position to refresh our storage platform. We saw it as an opportunity to also have a look at our offsite backup solution. We were running the tape infrastructure that it wasn't meeting our needs. It didn't scale to the size that we were getting to. Data was growing. We couldn't back up large data sets. We had our lecture capture data too large to actually fit onto the tape, so we won't send that offsite. Our tapes were stored in Sydney and it would take hours to arrive, and we needed somebody to actually get that tape loaded into the tape drive, and then we had to hope that tape actually worked. I've worked in previous places where a bucket of tapes has been dropped and we lost 2 years worth of data. So the reliability of tape is something to always play to my mind. And we also had unskilled staff going to the data center to swap the tapes around, and we were having operational problems with that side as well. So there was a lot of things that we weren't happy with our tape infrastructure. On top of that, our storage design, our backup design, was so that we replicated data between our two data centers. So we have a primary data center and a secondary data center. And then we chose what data was actually important to replicate. And then from that data that was replicated, we had to choose what actually went to tape. We didn't like that. We didn't like that one bit. So we did a heap of workshops leading up to the storage refresh and try to figure out what sort of tiering models made sense. And basically, the workshops concluded that all of our data is important. And we just made the decision right there and then that we were going to back up everything. We were going to push everything off site. And once we made that decision, it was pretty straightforward in how we're going to proceed. We spoke with Netalta, our incumbent storage provider. We've been with Netalta for over 15 years, as well as Katana One, our storage integrator, and they presented to us the Alta Vault, and we saw the Alta Vault as a way to modernize our approach. It's had a whole bunch of opportunities to reduce that operational overhead of managing the tapes that was consuming so much of our time, and the risk of those tapes not working. We saw it as an ability to speed up the time to recover our data, but most importantly, we saw it as a way to protect all of our data, push all of our data off-site and in a scalable manner. So what did we end up with? Well, to begin with, there was a few problems. We wanted the AltaVault because there was the promise that we could snap mirror to it. But from day one, when we first implemented this back in 2015, it wasn't supported. That support didn't come until 2017. So in the interim, we had to come up with a data mover. And that data mover, to begin with, was just us mounting the NFS directory and copying files directly to it. That didn't work. AltaVault didn't like having millions of small files, so lesson learned there, don't do it that way. Chris was talking about using an enterprise backup solution like the Veeams and Commvaults. We don't use any of those. We wanted to use that mirror, so we had to come up with something else ourselves. And we ended up just powering up all the volumes and then syncing them across. Wasn't great, but it was a short-term solution that until SnapMirror was supported, it got us through. We also looked at AWS as part of the decision-making here, and we saw AWS as a leader in the market. So it was a great opportunity to begin our shift to using cloud. We weren't doing anything at this stage back in 2015, and this is a great step into that world. We did some calculations on S3 and Glacier, and we understood the intricacies between the both of them, and we decided to begin with to go with Glacier. We hadn't restored anything from tape in the previous 2 years in anger, so apart from DR testing and auditing requirements, we hadn't actually pulled anything back from tape for our end users. So we thought, that delay for the reduced cost was worth it for us, and it was no different to what we had now. So we went down that path, knowing as well that in the future, if we wanted to change, it's going to be pretty trivial to go from Glacier to S3. We only use this offsite data in the event of both our data centers are destroyed or there's a problem on both sites. So the likeliness is low again. So that weight really wasn't too much of a concern to begin with. I recommend to everybody listening that you go through this process and understand the differences between each of the S3, SIA and Glacier, and then take that to your business and get them to decide what's best for you. So basically we were tarballing our data, we were syncing it to the AltaVault and the storing at Glacier. When SnapMirror became supported, we wanted to move straight to it, but it was a one-way upgrade, and our old data wouldn't be accessible post-upgrade. So before doing that, we wanted to make sure that we could actually access that data. So we spun up a virtual appliance, and we plumbed it into AWS, had a look at the bucket, we started to pull data back, and it failed. And we a little bit perplexed as to what was going on here. And we logged a job with NetApp, and we started investigating together. And it turned out that from our old days of copying data across, there was some symlink issues that was causing a problem. We worked with NetApp, we got it fixed, and that problem's all gone away now. But what it did do is highlight that, if there was a problem, we wouldn't be able to fix it. If this was tape infrastructure, we would never have tested this. So we were in quite a good position to be able to do our testing like that. So what do we do now? We snap mirror to the AltaVault. It goes straight out to SIA. We've made the decision after the upgrade to move to SIA. The Glacier delay ended up being not palpable for us. So we've made the decision, the business made the decision as well to go to SIA, and we're having much more success with our, and much more happiness with our retrievals. We've got the ability to test whenever we like. So not only do we test our ability to pull back from the AltaVault, but we also spin up new instances of the AltaVault, both in our data center and in the cloud, and test that access and confirm that it's all working. Again, we couldn't do that sort of stuff with physical infrastructure. When we have the auditors down, we get to do our compliance testing, and that's all happening seamlessly and really quickly. We're now about to implement a second AltaVault. So we're going to have one AltaVault for our primary data center. We're going to have a second AltaVault for our secondary data center. And it's now in an automated fashion where our snapshots are tagged and they just go straight to the snap mirrored straight to the AltaVault, from the AltaVault into the cloud. It's low touch, it's highly scalable, it's fully automated, and we're keeping our data for longer than we did previously with tapes. We have about 400 terabytes raw going into AWS, and that's been 400 terabytes going into the Alta Vault, and that's been compressed and deduped down to about 100 terabytes. Because we're using StatMirror, a lot of those efficiencies are already in place. If you're using any of those other backup tools on top of that, you get much more. When we were introduced to the Alta Vault, we were told about how effective its compression and dedupe was. We basically sat NetApp down and said, like, this is BS. This can't be right. We'd expect maybe 30%, not 30 times. And in those early days when we're doing rsync, we were getting between 18 and 20 times dedupe and compression. Now we're in the SnapMirror suite, we're getting about 4 to 5, depending on the data, and we're really, really happy with that. We've also got the Alta Vault on our roadmap for our storage grid deployment. Again, the Alta Vault can plumb into other S3-based systems. So we've been looking at doing that. So to us, the Alta Vault, with its data compression, its dedupe, its encryption, all the security capabilities, along with what AWS provides, it gives us this massive agility to do what we like. Our testing has never been stronger. Our operational touch on it has never been lower, and our costs have reduced quite dramatically over this time as well. We're really happy with the solution that we have here, and I'm hoping our story can help guide some people in their decision making. But I'll throw back to Chris now.
Okay, this is Mike. Thanks, Craig. I really appreciate those comments and kind of a description of the challenges and successes you had on the infrastructure. So we do have about 20 minutes, just maybe a few minutes shorter than that for open Q&A. I'm seeing a lot of great questions come into the question pane here. So the first question here, kind of a persistent theme. A couple of folks have asked this question, and I guess this would really be for Chris Wong. Craig, maybe you have some opinions about this as well. Is what are the tiering options? We talked about the different tiers available: S3, S3IA, Glacier. How does Alta Vault help us lane the different backups, or how do we make decisions, or how does Alta Vault help us make decisions about what sort of tier to use? And does it also provide a capability to move data between tiers?
Sure, I can answer that first part. Yeah, Alta Vault really is designed to work with all of the Amazon tiers and really help you to identify which tier is practically suited best for your data needs. For a lot of the users that we see, we really are looking now, I think, predominantly using either a combination of S3 and S3IA for those backup workloads, and then really focusing on archive workloads through to an Amazon Glacier target. Now, from a perspective of tiering, we generally don't recommend sort of mashing those use cases together, and I'll explain why. When you're using the Alta Vault plans, your most recent backups are going to be stored on the Alta Vault cache, which is a temporary space, of disks or back storage from your virtual infrastructure if you're running a virtual Alta Vault. And that will, provide you recoverability of, say, your last couple weeks worth of backup operations. Now, if you mix a archive use case in with this backup use case, what it can do is actually can impact your recoverability of those backup workloads, because your archive workloads that are intended for long-term storage are actually going to move those backups and cache off much more earlier than you would want them to. So from a tiering perspective, we actually would suggest that you actually deploy Alta Vault for specific workloads, that you have one specifically focused for backups and then one specifically focused for archives. And really that gives you the benefits of each tier, and it really eliminates a lot of the complexity of figuring out, okay, do I have the right amount of data stored on this tier? Is it being held for the right amount of time? And things like that. So really just a general best practice, I think we see, is to sort of manage and maintain these two tiers, separate tier backup and archive workloads.
Awesome. Craig, I'll pitch that over to you. From your description, it sounded like you had kind of originally used Glacier, but had migrated to S3IA, and that enabled some interesting workloads around kind of recoverability testing, which is pretty cool. Or do you see Glacier at any point in your future? Do you see you adopting or reintroducing Glacier into the architecture?
Yeah, we do. So, I mean, we, as you said, started with Glacier and we moved to SIA. We also started with our AltaVault in backup mode, and then when we redeployed with the SnapMirror integration, we moved it to archive mode, and that aligned much better with the way that we were actually using it. We didn't need that local copy because, as I said, we rarely do the pulls. But looking at Glacier, we do see that as part of our roadmap as well, because we have our library has 25 years of TV footage it wants to digitize. They need to keep a copy of that data, and they need the cheapest and deepest location. So the plan is to front the AltaVault with a small application and push that data into the AltaVault and into Glacier, and then just leave that data there. It's never going to get accessed again unless somebody in the future deletes all of our primary copies. It's a belts and braces, last resort sort of thing. So we definitely see Glacier as part of our roadmap and part of our strategy. Just for our enterprise data at the moment, we found that SIA was the perfect fit for us.
Okay, great. So that's cool. And just kind of a quick follow-up question on that. So a couple questions about kind of the structure of AltaVault. How does AltaVault lives as a virtual machine in the data center, but also in AWS? So just how do you have AltaVault actually deployed?
So we have a physical AltaVault. That was our first purchase. It sits in our data center. We also have a virtual AltaVault that we just got a license for at the end of last year, and that sits in a virtual machine that sits in our secondary data center. And they're both SnapMirror targets within our backup infrastructure. And it's once it's configured, it's kind of a set and a forget implementation from there. We have spun up the virtual appliance in AWS and confirmed that we can access the data from there as well. Another one of the reasons why I love this product is I can spin it up where I like, when I like, and get access to that data. So we're running both models at the moment.
Okay, great. Sounds cool. A quick question about encryption. Chris, maybe you'd like to dive in a little bit about how encryption works with the product, and especially key management. I know that key management for encrypted, when I was encrypting assets and sending them off-site, kind of lining up the recoverability with a key was sometimes problematic. And so I guess that this member of the audience is just looking for how you would guide a new customer for contemplating encryption with AltaVault and key management, any concerns that they might have or any best practices that you might be able to share.
Yeah, certainly, Mike. So encryption on the AltaVault is a requirement. It does come with the requirement that you set up an encryption key to ensure that your data is stored safely on the device as well as in Amazon today. The encryption key that we establish can actually come in a variety of factors. So we can either generate one on the appliance, or if you have an encryption key that say you use across your organization, you can encrypt that, bring that encryption key either as a file or as text onto our appliance as well, and we will use that key for your encryption needs. The encryption key will encrypt basically all data from this point forward. So it is a singular encryption key that obviously you need to keep secure from the perspective of security aspects. But from an AltaVault perspective, we do protect that encryption key from being retrieved, and we have the ability to password protect that encryption key so that it can not be accessed without knowledge of that passphrase. And then we also have the capability as well, if you have key management requirements and say you can't have an encryption key locally on the appliance, to use a KMS or a key management server that's on your on-premise environment as well. And that can hold your encryption key as well as your Amazon Cloud credentials safely and securely, such that those credentials are then passed to AltaVault at any time you need to do a cloud operation to or from Amazon.
Okay, that sounds great. Craig, do you have any comments about kind of best practices or your experiences with key management with AltaVault or AWS more generally?
Yeah, it's key management's a tough problem that you really need to spend a lot of time thinking about it. We're old school at the moment. We actually print out the key and we put that printout in 3 physical locations across the campus in massive fireproof safes. And that's part of our DR procedure as you go into there and you get get the information, you can access your Ultravol and your AWS. We are looking at doing this a little bit more clever in the future and try to use some of those tools that Chris just mentioned. At the moment, we're not exactly happy with the printout, but it's just a legacy way that we've been doing it. We did have to have a look at the way that our accounts were created in AWS. It does present a new problem that physical tapes don't have. So while your data is online, you still have that problem. And we've worked through that with setting up some workflows in how to get access to those accounts, how those passwords are generated, and that sort of works in with some of our other secret management that we do here. So it wasn't too much of a problem for us, but it was something new that we had to tackle when we took on the Ultravol. Great,
understood. It remains a complex problem. A quick question about Snowball. So this is an AWS service that I did not mention, but probably should have. So thanks for bringing it up. Snowball is a physical appliance that Amazon or AWS can ship to your location or the location of your choice. You can plug it into your network, copy data over to Snowball in the terabyte range or the dozens of terabyte range, and then ship that back to AWS, and AWS will upload that data to S3. So this is a way to quickly move data from on-premise or kind of in the field. We see folks interested in this, in oil and gas exploration and other places where we're generating a large amount of data in the field. AWS or Amazon can ship a physical device to your location. You can load it up with data, send it back, and it'll appear in S3. The nice thing about that is that you can also reverse the streams. You can bring data. You can set up a job to copy data to a Snowball from S3, then ship that anywhere in the world as well. And so this might be an interesting way to use Amazon as a way to process your data and then move it to some other location that's convenient to you. So that said, does AltaVault support Amazon Snowball? I guess this would be a question for Craig. For seeding or standing up the sorry, Chris, is standing up the initial backup or recovery workflow. Sorry, the initial set of objects for seeding.
Yeah, so exactly. So the Snowball appliance is really designed for those large workloads that might not necessarily fit over a WAN to Amazon in a decent amount of time. And we have customers that have looked at using a Snowball to basically do a seeding operation of their base backup operation to an Amazon target. So we do support that today with the Amazon Snowball appliance, and really it's quite simple. You basically do exactly as you described. You order a Snowball from Amazon, you bring it on site, connect it to your network, and basically it acts like a local cloud target for all intents and purposes from an AltaVault perspective. You'll just sync up your data set that you've received from your backup application to the Snowball, and then you'll send it back to Amazon. It's a ruggedized device, got a shipping label built into it. All you need to do is basically just do a quick handoff of that back to your courier, which will arrive back at Amazon's data center. They'll upload it back into your public storage bucket, and then AltaVault will then sync any remaining incremental changes off to your bucket, and you'll be up and running and achieving again all of the deduplication and incremental optimizations of that storage efficiency, so that you can continue operations normally over your limited WAN link to Amazon services.
Okay, great. I get it. I get really excited and geek out a little bit on Snowball. The mailing label that you mentioned is in fact, or used to be in the version I saw, a Kindle. So it's an e-ink display that kind of magically updates itself. It's kind of leveraging Amazon's, I guess, deep strength in shipping things to customer locations. So anyway, quick other question, and maybe this is more of a question for you, Craig. I think you mentioned it briefly, but it sounds like you're not actually leveraging a quote-unquote traditional enterprise backup solution. It sounds like you're really just using your own tooling and kind of the snapshot and file systems approach to move data out using AltaVault. Is that right?
Yeah, that's correct. So there's a couple of reasons for that. One is I got a team of gifted programmers that are very good at setting all these deployments up themselves. The other thing is we still run Solaris. We have a mixture between Solaris Spark and x86 infrastructure in our data center. And when we look at these backup, enterprise backup tools. So they've got all these great capabilities, but they don't do much for us in the Solaris space. And the majority of our tier 1 applications and services still reside on Solaris. We've made the decision that we're going to move away from Spark and into x86, and we're going through our testing now of how that's going to look. So in the future, we may look to run an enterprise backup tool on top, but our backup strategy is SnapMirror. If anything's got SnapMirror as a target, we considered it as part of our backup. So on our primary site, by default, we have a policy-based storage architecture that the guys have built themselves, where on the primary site, when you build a volume, when you build an SVM, when you build any type of storage, by default, you get 30-day snapshots. Those snapshots are replicated to the secondary site, kept there for 30 days, and then as part of the policy, those once a week, those snapshots are migrated to the Alta Vault, which is then pushed out to the cloud. So it really is, having the Alta Vault be SnapMirror capable really just tied beautifully in with our backup strategy.
Okay, great. And this is a little bit more technical, but so it sounded like you were using Symlinks and NFS. And Craig, if you know, I'd appreciate an answer. Otherwise, we can pitch it back over to Chris. But do you know that if SIFS works the same way as NFS in this context?
So you can mount the Alta Vault both NFS and SIFS. We were doing NFS, and I bring that up as a tie into the flexibility of being able to test the system, but that was way back in our early days when we were just testing. So I wouldn't recommend copying and using the NFS mount as a file directory. I'd recommend using a data mover, either the SnapMirror suite or one of those enterprise backup ones, because they handle that job perfectly, and there's no integration problems there that we've seen.
Okay, that sounds great. Oh, go ahead, Chris.
A quick response to that. From an Alta Vault perspective, the appliance is designed for really large sequential workloads, such as those driven by a backup application data mover. And we really would, prefer to see those workloads in order to achieve the performance targets that we specify, for the appliance, in the terabyte per hour, multi-terabyte an hour backup range, for example. Having the Alta Vault service as a general purpose NAS appliance is not Alta Vault's strong suit, and it's generally not recommended to be deployed in that particular fashion to back up lots, or do a drag and drop of many small files, or to back up a user's home directory, or organization's home directories. That tends to run much more slowly than with large backup jobs. So I just wanted to point that out with regards to how Alta Vault operations are optimized.
We were actually told that to begin with, but we chose to ignore that advice and test it for ourselves. And we experienced the pain, and we understand now why that's the case. So hopefully, that lesson learned is our pain, somebody else's gain, and they're not going to go down that path as well.
Sounds good. And this is just a question for you, Craig. So it sounds like you were able to reduce your TCO significantly through this process. Do you want to take a stab at kind of what your sorry, not your RTO, apologies, but so your recovery time objectives, have you been able to reduce those with the introduction of Alta Vault versus your tape, your previous tape infrastructure, and kind of what do you suppose those are these days?
Yeah, so we don't run official RTOs or RPOs, but we have seen a dramatic decrease in that time. When we ran tape, we were looking at potentially days before we were getting that data readable. Now we're kicking off the job immediately. We're seeing that data come back down, and within half an hour to an hour, we're getting that data back and being used in anger again. So it has dramatically reduced, and we're really, really pleased with that. It all depends on the size of the volume that we're pulling back, obviously, but seeing the data come back, which you would have to read from the tape anyway, immediately, has been a big benefit for us.
So thank you very much, Chris Wong and Craig Muller. I'd like to invite the audience to try NetApp Alta Vault. Chris mentioned it briefly, but it's available for a one-click deploy out of the AWS Amazon.com marketplace. Search for NetApp Alta Vault. Of course, you can learn more about NetApp and AWS at netapp.com/AWS. And as always, feel free to try AWS for free. Log on, try out that console experience at aws.amazon.com. Thank you so much for your attendance, and good day.